A couple of things that we need to know about our graphing calculator when it comes to solving our calculus problems. When it comes to decimal answers, we're always going to round to three decimal places. This is not three significant figures, this is just three decimal places in general. A couple notes about your calculator. We want to make sure that you're always in radian mode. So if we turn our calculator on, and go to our home screen, we can click on mode and just make sure that the radian mode is highlighted. Couple of things that we should be able to do in our calculator. We should be able to graph functions, turn those graphs on and off, change your windows, find specific values from a function, both from the home screen and from the graphing window, finding intersection points between two functions, finding zeros and local extrema, and then be able to kind of generate a table, both an automatically generated table, but also an ask mode. So you can ask for specific values. In terms of the calculus, there are certain features in the calculator that built into it, including finding derivatives at specific points, and also creating the graph of a derivative is also possible in the graphing function on here. So we're going to take a look at this example. I've got two functions here, an exponential function as well as a rational function, and we're going to run through how we would do these five different aspects that are on here. So first things first, you're going to actually get the f of x and g of x function into your graphing calculator by hitting y equals and typing it in there. Right now, my calculator is in the classic mode. If you have the ability to do math print, you can find that under mode and to arrow down. And there is the option for math print versus classic. So with the math print, here is what your functions would look like. You can see that the square root is over the 6 minus x completely, and the exponent for e to the x over 2 has been raised to create that exponent. So we're going to switch back and forth so you can kind of see both views and what these look like. The first thing we're going to do is actually change the window for this. When it comes to zoom, there are two great zoom options that you should really be familiar with. Hitting the zoom button in the middle, we are going to hit zoom 6, zoom standard as our first one. And here is our exponential function, and then the rational function being graphed after that. As you can see, these kind of overlapped a couple of times. There's a couple of intersection points that we have. One of the things you can also take a look at is zoom decimal, which is option number 4. I really like zoom decimal because of the way that the scale works when you're tracing. It's also a really nice center around the origin of 0, 0. Here's what I mean by the tracing. If you hit trace on any one of these and you arrow over or arrow to the right, you're going to see that the x's are increasing by 1/10 each time. So you get some crazy y values for these particular functions, but the x values are kind of nice domains that they're looking at while you're tracing this around. Also, as a reminder, when you're looking at the trace button at the very top of our screen, it says y1 equals. So it shows me what function I put into the y1. If I wanted to see y2, I'm going to hit one of the up or down arrows to toggle over to the other functions. And if you had more functions in your y equals menu, then you would be able to continue to toggle between all of those by hitting the up and down buttons. So we're going to find the intersection points of F and G. Right here, I can see actually both of them we've got one all the way over on the left and another one over here on the right. So to find those, we're going to go into the Calc menu, which is above that trace button we were just using. I'm going to hit second and then Calc and go down to option 5 where it says intersect. Now, because we have two different intersection points, we do want to get relatively close to one of them first. So I'm going to use my right arrow all the way over there. And when it says first curve, I'm just going to hit enter. Second curve, just hit enter and guess hit enter. If you only have two functions graphed, you can just continually to hit enter and it'll find you your intersection points. Here we have, again, rounded to 3 decimal places, 1.583, comma, 0.206, or you could leave it as 0.207. Either way of rounding would be accepted. we still have a second intersection point to find. So at this point, you can use your arrow over button to continue to kind of move your cursor all the way to the other side of the graph. Or if you go to second intersect again, because that cursor kind of got moved back to where I originally was, what I would do is actually type in an X value that's a little bit closer to where I think the intersection is. So I think somewhere around -4 looks to be the place where this is going to be. So I'm just going to type in -4. Let's try that again. I'm just going to type in -4. Oh, maybe that's not going to work with this one. So here's what I'm going to do instead. I'm going to do value and type in -4. There we go. And that jumps the cursor over to the other side of the graph. And then I can do my second calc intersect. And since I'm closer to that second intersection point, it'll find that second one for me at -4.352 or 353, and then -1.886 or -1.887, depending on how you'd like to round. The next option says to find the zeros of f of x. So what I'm going to do is I'm going to go back into y equals and turn off my second function. I don't need it anymore. So I'm going to highlight the equals button and hit enter to unhighlight it. And now I know that I will not have that second function showing. And then I'm going to go back and do a zoom 6 one more time so I get a better look at my exponential graph. So I have 1 0 located on here. To find that x value, I'm going to do second and calc. Go down to the second option of 0. And this time it asks you for bounds, and they're basically asking you for a domain that contains your x-intercept. So a left bound just means we need to find a domain value on the left side of our x-intercept, and then the right bound is going to be on the right side. So left bound, I'm just going to hit enter. I'm going to use my right arrow to arrow over a little bit more. And I'm going to find my right bound. And the 2 arrows that are showing up in here should be kind of representing the domain in which the 0 is located. And I'm going to hit enter, and it'll tell me where my 0 is at a 1.386. Now finding f of 3 2 different ways. One of the ways you can do it is from the graph itself, and we've already kind of glimpsed at this real quick. Second calc menu, the very first option is a value. So if you have your x coordinate and you want to find the y value, you can select this option, and it'll just ask you for what x you want, and we're just going to type in 3. So we know the y value is 2.481 or a 2.482, depending on how you would like to round. You can also do this not on the graph, but actually on the home screen. So if I hit second and quit and go back to our main screen here, this can actually find different values for you as well. So what I'm going to do is I'm going to say I want the equation that I put into y1. That's the equation that I'm referencing. So I'm going to hit the vars button, which is next to clear. I'm going to arrow over to y vars, which stands for the different y variables that the calculator has programmed in. And we were working with functions. We were working with just normal functions. So I'm going to hit enter at functions. And here is a list of all the different y equals equations and all the spots that we have to type in different equations into the y equals menu. I typed in f of x into y1, so I'm going to hit enter at y1, and it brings that to the home screen for me. After this, what I'm going to do is I'm going to open up a set of parentheses and just type in the value that I'm looking for, the x value that I'm looking at, and then hit enter. And it's going to also tell me that same exact y value. So this is essentially doing some function notation right from the home screen. So we're actually going to do a third way to do this as well, and it has to deal with the table. So if I just go into my table second and then table, you'll see that my table is automatically generated with intervals of 1, starting at 0 and continuing on. And I can actually see here's 3, and I can arrow over to see the full decimal that's in there. So it's actually a third way. But to modify this table, if I only wanted to find 3, or let's say I wanted to find 3.5, we can modify this table just to focus on the specific values we want. To do that, that's in the table settings, and it's abbreviated as TBL set. It's above the window button. So we're going to hit second and table settings or setup. And here you can change which value you want to start the table at and also how much you want to go have a change in your x coordinates. But down here for independent, you can also arrow over and select ask. And what this does is leaves the table blank until you decide what x values you would like to look at. So if I wanted to know about x equals 3, I would hit enter at 3 and then enter. It would tell me my y value. If I wanted to find out about 3.5, I could just type in 3.5. And then let's say 20 was a particular number I was interested in, I could just type in 20. So we don't need all of those extra in-between values that we're not interested in. We can just focus on the x values that we care about. The next thing that we're going to do is find the derivative of f at 3. So if we go back into our graph feature and we look at this, and I'm going to go back to a value of around 3. We think about that particular point and think about what the tangent line looks like. That tangent line is going to be having a positive slope, but I want to figure out what that slope value actually is. So back in your calc menu, so second and then calc, there are two calculus related operations down at the bottom, and option number 6 is your dy over your dx, standing for your derivative. So we're going to hit option number 6. And then right now, if I try to arrow to the left or to the right to find the point, I'm not going to see 3. So I actually have to type in 3 in here. So I'm just going to hit a 3 and then hit enter to confirm that's the place where I want to find the value of my derivative. And at the bottom of my screen, I see that the dy over dx would be a positive 2.241, probably with my rounding. Now, just like the graph, we can actually figure this value out from our home screen as well, just like we found the value at 3. If we wanted to find the derivative at 3, we need a entirely different menu and different option. The derivative is found under the Math button underneath Alpha. And underneath your Math button, you're going to have to scroll down a little bit to try to find your calculus-related items, and that's related to number 8 and number 9. The NDeriv is one of your menus that helps you to find values related to your derivative. So I'm going to select NDeriv, and if you're in the Math print, it actually sets up the derivative notation for you rather nicely. You're going to need to include your variable in this. So it's going to be d over dx. So you want to use the variable button that's next to alpha to type in your x. The function we are using, you can either type in the function itself. So I could do e raised to the x divided by 2. Arrow out of that, and then subtract 2 from there. So I could actually type that all the way in like that. And then down here at the bottom, we're going to type in the fact that we want to evaluate this derivative at 3, and then hit enter. But I can also just, since this is already in y1, I can also just type in that y1 as well. So I'm going to go to Math. Option number 8 is my NDeriv. Make sure I have my variable x. And then I'm going to hit vars over to yvars, function, and y1. And then arrow over to evaluate this at 3. And I'm going to find the same value of my derivative. Now, if you are a person who has a calculator that only does the classic, your NDeriv setup has a slightly different look to it. So we're going to go through and change this over to the classic and go back to my home screen. And here's what this looks like. So math number 8 for NDeriv, you have to type in a series of your information separated by commas. So the very first thing that you're going to put in there is your function. So I'm going to do the same thing that I did before. Vars, yvars, function, and y1. I'm going to hit the comma, which is above the number 7. Type in the variable that belongs in my equation, which in this case is x. Separate it with a comma. And then type in the value that you're interested in, which in this case is the 3. So again, for n-deriv, it would be your function, your variable, and the number that you're evaluating at. Those are the three pieces of information you need to type in, whether you have the classic or the MathPrint type setup. The last thing is this n-deriv function in here, or our operation that the calculator has, can actually help you graph what the derivative is going to look like. So I'm going to go back into y equals and arrow down to y3, and I'm going to make y3 the derivative of my f of x function, of the exponential. So what I'm going to do is actually start off with that n-deriv. I'm going to do math, option 8 for n-deriv. I'm going to do my y1, comma, variable x, comma, and instead of just a single number, because it's only going to have one particular output, I'm going to put in a second x, which lets the program know that I want to evaluate this at every single possible x value that's on my graph. What I'm also going to do is I'm going to arrow over and make this a bolder line so we can tell the difference between our original function and the derivative. And let's do a zoom 6. Here's our original exponential function. And then in bold, here comes our derivative. Also an exponential function, which we expected. Also, it raised its horizontal asymptote to 0, which is also kind of expected given the fact that the 2 in our function would disappear. And there we have it, our function and its derivative. If you are somebody who has the MathPrint, here's what this would look like. If I go back to mode and select MathPrint and go back to y equals, you'll notice that we have to still enter in that variable x for the d over dx. We still have our y1. And at the very end, instead of x is equal to a number, we would just leave it as x is equal to x, so the calculator knows to evaluate at all the different x values that are on the graph. So the way I've showed you works for all of the TI-83s and 4 types of calculators that are out there. There is also a couple of shortcut menus that some of the calculators have in them, specifically related to the F1, F2, and F3, F4, and F5 menus. So if you hit alpha and then F1, you'll see that there's a couple of shortcuts that open up, things related to fractions. If we arrow over, we have some functions. So you know what, I'm actually going to hit alpha F2, so we get the function menu in there, and we can see the absolute value summation, and then option 3 right there is your n-deriv. So there's a shortcut rather than going into the math menu. Also, if you arrow over, or I should say go to F4, F4 is your Y variable shortcut as well. So if you're not a fan of going to vars and then Y vars and then selecting the function menu and then finally picking where you put your equation, alpha F4 brings up your available Y variable menu as a little bit of a shortcut.